Okay, here we are using the extreme value theorem. This is probably more in your wheelhouse. You're going to enjoy this a little bit more than some of the proofs problems because it's more about calculation and solving for a particular value here. So you can think of it, if you think of the speed camera example that we referenced in the last video, you can think of this type of problem as solving for the exact moment that you're speeding. So what this will look like, so here's an example of a problem. It's going to give you a certain interval, so x equals -3 would be at this point here, and x equals 5 would be up here. And you're going to draw the secant line through those 2 points. And then we want to find the values of c, which satisfy the conclusion of the mean value theorem. So these are all differentiable and continuous. We don't have to worry about the hypothesis. We just have to figure out where the derivative is equal to the slope of the secant line. And I'll show you real quick how this looks in delta math too. Okay, so what you'll do is you'll draw the line. So I clicked on my first point, and then I'm going to click on my second point here. And again, these are given to you in the text. And then you're going to calculate the slope, okay? So it will ask you for values of c. So my first move is going to be to figure out the slope of the secant line. So I'll do that work here. So my secant line, remember, we're going to use that average rate of change formula. So f of a minus f of b over a minus b. Okay, so what would that get us here? We get, on the bottom, we know at least, we're doing -3 minus 5 because those were our two x values that were given. Now, the top can be a little bit hard to see. So I might estimate like 5 based on this graph and 35 based on this graph. But really with this scale here, I want to be a little bit more precise than that. So what I would want to do is plug these values into this function. So I'll do that real quick, and you can just do that in your calculator. For f of -3, you do get 5. For f of, what are we looking for? F of 5, you get 37. So if I had just estimated based on the graph without plugging in those points, I would have gotten this one wrong. Okay, so that would be 5 minus 37. And then when I simplify, I get -32 over -8. Which is just 4, right? +4. So the slope of this line is 4. Now, we want to know, our problem now becomes, find a value of c such that f prime of c is equal to 4. Okay? So first step, find the derivative, and that's just a power rule derivative. So we're going to subtract 1 from each of the exponents, then multiply. F prime of x equals 3x squared minus 4x minus 11. Okay. Now you can probably guess what the next move is. If I want this to be equal to 4, well, I can just set it equal to 4, and then I have an equation that I can solve. Okay. And what I would do here, get this function equal to 0. I believe these all end up being quadratic in this particular problem set. And then I would solve by factoring. So what we get here, 0 equals 3x, x, and I think +2, or +5 rather, and -3. Okay. So you can factor by grouping. You can also find these zeros on your calculator, however you prefer. And maybe we'll do a calculator example in the next one. So here I'd say 3x plus 5 equals 0. That's going to give me x equals -5 thirds. And here we get x minus 3 equals 0, and x equals 3. Okay. So those are my two solutions. That means if I draw a tangent line, and we can even see, we'll look at x equals 3 here. The tangent line at x equals 3 on the graph is parallel to that secant line. That's what we're looking for. So here, these would be our two solutions. All right. So steps here, find the slope of the secant line and work precisely when you do that. So check, don't just estimate based on the graph. Set that slope equal to the derivative and then solve for the x's that make that equation true. We'll do one more. So we have our same function, or same type of function. We have a polynomial, and we are looking for the points where x equals 1, so that would be here on the graph, and x equals 6, so that would be here on the graph. And this is an interesting example because this secant line is horizontal. So we don't have to do the math here. We can just say that the slope of this line is 0. So this is kind of a special case, right? So, and you could obviously check by plugging in these 2 points into your average rate of change formula, and you'd get 0. But like, if you get a horizontal line, don't bother because we know that those slopes of horizontal lines are always 0, and that's pretty easy to see from the graph. Okay, so we want to find a point where the derivative, we want to find a c where f prime of c is equal to 0. Well, that should sound familiar, right? So really what we're looking for is the minimum, right? We're looking for that critical point here. So we already know that this is going to be at that x equals 4. But let's just solve it so you can see another example. This, by the way, is a special case of mean value theorem. It says that if the slope between 2 points is 0, then the function has to have a maximum or a minimum in between, right? Because if there's no change between the 2 points, that means it has to change. The function has to either go up and then come back down, or go down and then come back up. It's called Rolle's theorem, which you don't have to know, but you may see it later in your math career. It's about like this, Rolle's, named after a guy named Rolle, I would presume. And again, you don't have to know that for the purposes of this class or really the AP exam, but it's a good thing to just have heard before. So I'd say 0 is equal to my derivative, which would be 3x squared minus 10x minus 8. And then there's a couple of different ways your calculator can help you here. The easiest way is to just type it into the grapher. So make sure it's equal to 0, type it in, and then draw the graph. And we get a parabola, which is what we would expect, right? I'm going to make sure I'm zoom standard, so I'm going to do zoom 6. Just to double check. And then we're looking for a point where this is equal to 0. So I can do second, and then trace, calc, and then 0. And left bound or right bound? Okay, we are looking between 1 and 6, right? So let's make our left bound about x equals 1. It doesn't have to be exact. And our right bound be about x equals 6. And then hit enter. And it finds that 0 is x equals 4, which is what we expected based on the graph, right? Notice there is another 0, but we can ignore that 0 because it's outside of the bounds we originally picked, right? So our original problem asked us to find the slope between x equals 1 and x equals 6, and this 0 is obviously less than 1 because it's a negative x value. So we can ignore that here. Okay. So based on the result from my graphing calculator, I can also say that this equation gives a result of x equals 4 and something else, but the something else I don't care about. Okay. So that is the application of the extreme value theorem.